Hey, welcome back to Southern Iowa Luddite, where on today's episode, we're going to titrate the sunflower oil that was previously isolated via centrifugation. We're doing this so that we can understand how much catalyst, sodium hydroxide or lye, to add to the sunflower oil, and then with the proper amount of methanol so that we can produce some high-grade biodiesel. So let's get into this. Okay, so here's what we're going to need today to do this titration of the sunflower oil that we purified via centrifugation on the previous episode of Southern Iowa Luddite. So we're going to need some basics here. We're going to need a 10 mil syringe, a 1 mil syringe, a 3 mil syringe, a couple 50 milliliter plastic beakers, just a plastic spoon, some 1% phenolphthalein indicator titrating solution, a small sample of our sunflower oil previously purified, some 99 plus pure sodium hydroxide, because we're going to produce the biodiesel from the sunflower oil with sodium hydroxide as the catalyst. You could also do potassium hydroxide, but we're going to do sodium hydroxide. Source doesn't really matter, it's the purity. We get this from Biodiesel or Duda Energy LLC. Check them out. They're great for all things seed oil and biodiesel. We use a lot of their filter and processing aids on our commercial scale operations. We've got some high purity isopropyl alcohol. You really want that, that industrial grade of that 99 plus. Some water. We have just a cheap jeweler's balance that we can read to 0.01 grams. You need at least 0.10 grams accuracy. We have another balance that goes to 1 gram accuracy. We have a bottle that can hold a liter of water because we're going to make a titrating solution. We just want to make it once. Old chemist trick here is I tear the bottle in case I forget to tear everything as I'm transferring a reagent into it, and then that way I can weigh it with everything in there, subtract the weight of the bottle, and know what how much of the reagent I put into the bottle. I need some sort of writing instrument and some protective gloves for the isolation of the lye to transfer as a solid into the 1 liter bottle with water. Okay, so let's get started here. So the first thing we're going to do is we're going to tear the bottle and the funnel, and we're going to accurately weigh out 999 grams of clean drinking water. Okay, that's exactly 999 grams of clean drinking water. Now we want to put our gloves on because we're going to grab some lye. And so we're going to tear an empty beaker here. And the thing about lye is, especially today, it's kind of wet and rainy out. You don't want to expose it to air very long because of the moisture content in air. So I like to cover the container back up and then do what I use what I need and throw the rest away. Okay, so I overshot that a little bit, so get rid of that. And this is kind of a microgranular form of sodium hydroxide, so it's pretty nice to weigh out. Still a little bit too much. go. Right at 1 gram of lye. So instead of trying to put this and transfer it that way into the bottle, an old chemist trick is to add some of your diluent and we'll mix up the lye here. Let it dissolve, and then we'll transfer everything back into the bottle. This is how you get a quantitative transfer. Or as close to it as you possibly can. Okay, so we'll pour that, hopefully successfully, back into the bottle. These beakers are nice. They've got a little pour spout on them. And there we go. Now we have a titrating solution that's going to be good for 3 months. We'll give this a good mix. We'll write the date on it. And we can use that for approximately 3 months. Okay. So the next part of this is we need to take some of our sunflower oil, and we have to take some isopropyl alcohol, and we're going to put 10 mils of isopropyl alcohol into beaker A, and then we are accurately going to put 1 mil of our sunflower oil into the isopropanol or isopropyl alcohol, mix it up, and then that's what we'll titrate after adding some of the phenolphthalein. So first thing to do here is to get 10 mils of isopropanol. So we'll overshoot that and then push the syringe back to 10 mils. So we have 10 mils of isopropanol. And again, you want to cap your isopropanol too. It'll pick up water. Now we're going to get 1 mil of sunflower oil. Here you don't want to pull very fast. It's kind of viscous. And if you do it just right, you can get the 1 mil without a bubble. Knock the excess off. Transfer a mil of the isopropanol, a mil of the sunflower oil to the isopropanol. Stir it up. Okay, that looks pretty thoroughly mixed. Now we're going to grab exactly 3 mils of our titrating solution. So we're going to give this a little more shake. But first we're going to add 2 drops of phenolphthalein indicator. So there's 2 drops. Mix that up. And what we're going to do is, as we add base here, there's going to be an acid-base reaction with this indicator. And effectively what we're doing is we're titrating the free fatty acids here. And so then there's a tried and true formula that you can find just about off of any biodiesel manufacturing website, and even from Due to Energy, and understand how to plug that into equations. So then ultimately we know how much catalyst and how much methanol to add to a known amount of sunflower oil to convert it as closely as we can perfectly to biodiesel. So we're just going to have a few drops at a time. We want to stir it. Once it holds its magenta color for 30 seconds, then we're at the end point. So you can see it's making some pink, but if I stir it, it's going to disappear. And I know from a off-camera run, there's going to be about 1.2 milliliters or so of titrate. So I'm going to add it fairly quickly here, but just want to add a couple drops at a time, stir it, see if the pink lasts. We're getting a little more residual time in that. So we're getting close. It's one of these things though, a little bit at the end really holds it. It's at literally that final drop. But you can see we're starting to get a little residence time of some pink there. So we'll add another drop. And as predicted, 1.2 mils. So I want to write that down. .2 mils of titrate added. I'll go off camera here, do some calculations, tell you what our ratio of sodium hydroxide to liters of our sunflower oil is going to be when we do the biodiesel production step. So see you in a moment. Hi, I'm back. So did the calculations. We're going to need 6.225 grams of our sodium hydroxide catalyst for every liter of our sunflower oil that was previously purified via centrifugation. This is an important number to calculate on the free fatty acids, because if you overcharge the sodium hydroxide catalyst, you will make soap, which will really make impure biodiesel. It'll make a terrible emulsion and be hard to purify. If you undercharge, you won't get a complete transesterification. So that number is really important. It is a nerdy video, but it's one you got to do if you want to make high quality biodiesel. We're going to use the traditional ratio of 6:1 methanol to our sunflower oil in the next step. So thanks for tuning in. Really appreciate it. And as I always say, get it done with what you got. Have a good one. See ya.